What exactly is quantum mechanics? Quantum mechanics is unlike anything you already know. It's the way that we describe the motion and interaction of subatomic particles. When things are incredibly small, the language and tools we use to describe them is different to our normal scale. The first thing you have to become comfortable with in learning about quantum mechanics is that you cannot compare it to anything else. You have to approach it like learning a new language. If you truly want to understand it and use it, you have to learn that language to really know how to put the tools together. Quantum mechanics at its core is about probabilities. In classical mechanics, you describe something by its time and position coordinates. In quantum mechanics, you describe something through its probability of being in a position at a certain time. There are a few principles in quantum mechanics that are important to start understanding it. First is wave-particle duality. Particles can show wave-like characteristics, and waves can show particle-like characteristics. Second is the Heisenberg-Schrödinger model of the atom. Each electron acts like a wave around the nucleus. They occupy specific orbitals and adhere to a wave function. The wave function is a complex function that describes the system using probabilities. Third is the uncertainty principle. We can't accurately know both the position and momentum of a particle at the same time. We can only know one property with more certainty than the other. Fourth is superposition. Schrödinger's cat is a thought experiment about a system that's in a state of superposition. The cat is not either alive or dead until the box is opened. It is both alive and dead at the same time. Only when you open it will a specific outcome be determined. It is in a superposition state. Fifth is entanglement. Two particles can be set up so that their quantum states are correlated with each other. They are described by the same wave function of probabilities. When you perform a measurement on one, the superposition state is removed and the specific outcome is determined for both particles in the system. And lastly, there is the missing piece, quantum gravity. General relativity describes the large-scale universe, and quantum mechanics describes the small scale. But to date, there is not a suitable connection between the two that allows us to have a full description of everything, a theory of everything.